Okay, so the 29th problem in the lead code is to divide the two integers. Okay, so basically here we'll be given the two integers, we'll have to divide it. Okay, we'll have to divide it and we'll have to return the quotient. Okay, but the catch here is we should not be using any multiplication, division, or the mod operators. Okay, uh, okay, so now as we know, like we are not supposed to use this. Okay, let's see the approach. Okay, before actually directly jumping into the code, we'll see how we can approach this. Okay, first we'll take an example. Let's say maybe 33 divided by 10. Okay, how we solve this? Ideally we know that 10 ones are and 10 3 will be the maximum multiple, right? 10 threes are, that will be the answer, right? 10 into 3 will be 10 into 3 will be equal to 30, and remainder will be 3, right? This is how we approach, but the thing here is we are not supposed to use the multiplication operator, right? So what we can instead do is we can say that I will keep on adding the 10, okay, until I get the value that is less than or equal to 33. Okay, so let's say that I will add a 10 which is less than or equal to 33, correct? And then again I will add a 10, then again I will it is 20 is less than 33, again I will add how many times I'm adding it, that also I need to make sure that. Okay, and 30, that is also less than 33, and again I will add one more and it will be 40. 40 is not less than 33, right? That is not correct. Like I mean we'll now we are crossed the limit, right? So now whatever the quotient, right, only this is the value. I need to be keeping the track of how many times I'm adding it, that will be my quotient, right? This is the one approach. Okay, so now let's say that 33 by 10 we have added for 3 times and we got my answer. Now let's say that I am doing for 33 divided by 2. Just imagine how many times I will have to. This is like I just reduced the divisor. So how many times I will be doing? I will have to write 2 plus and check if it is less than or equal to 33. All right, I will be keep on doing it until I get the answer, and we know the answer. Yes, this is a like clearly we can do this calculation, right? This will be nothing but a 16 times, right? 2 ones are to 16 the 32, and we know for 16 times I will be adding it. Okay, that will that will increase the time complexity, right? How many calculations I will have to do for this simple calculation, right? So now to avoid this, what we can do, right? Let's say that now I'm checking for individual numbers. I'm adding individual numbers. I'm checking if it is less than or equal to 33. It would be good, right? Let's say that I checked for 2 now, and next time I will check for 10, right? And next time I'm checking for 20, and next time I'm checking for 30, right? This way, instead of 16, I just reduce my operation time to, like I mean the iteration time to 4 times, right? That is like improving the time complexity. But how we can do it, right? Let's say that we'll need some logic there, correct? I cannot directly stop it at 4 and check it, and directly stop it at 10 and check it, 20 at 30 and check it, right? So what we'll do is we'll maintain one rule that we'll be multiplying it. Let's say that now whatever the value, right? One second. Okay, so now, right, so we'll be taking the multiples, correct? Yeah, yeah, instead of multiplying again, right, here we have the chart, correct? Like so to get the value to 33 divided by 2, I will be doing for 16 times, right? And also we need some logic so such that we can skip some iteration, right? Instead of going each over the element, we can skip some. So let's do one thing. Let's as we know, this will be our constant, correct? How many times I'm adding my number, that will be my constant. This will be my constant. Okay, the second one, this will be the, like I mean the divisor, and this we are trying to reach towards the dividend. Okay, and now what we'll do is instead of calculating for each, right, what we'll do is double it basically, right? Instead of directly checking each iteration, we'll double it so that we can reduce the calculation. 2 4 4 to 8, and 8 to 16, and 16 to the 32. Okay, and again if you go behind, it will go to 64. That we don't need it, right? It is the greater than or equal to the dividend. Okay, so just by looking at it, instead of doing it for 16 times, how many times we have reduced it? 1, 2, 3, 4. Just by 4 iteration, we have got our solution, correct? So this is a like I mean simplified approach basically. So what we are trying to do is initially we were at, like I mean 33, and 33 divided by 10, we added our 10 to the 3 times. So now what we are doing is we are jumping, like I mean we are doubling our quotient basically, right? Like I mean 2, and it is 4, and it is 8 and 16, right? We are doubling it and checking if it is if we can directly go to that point or not, right? So instead of doing all the middle calculations, so now again what we are trying to do here is we are trying to double our quotient, and we know that we are not supposed to use the multiplication operator, correct? but we still need to double it somehow. Okay, so for that we can make use of the binary operations. Okay, to give the summary about it, let's take an example of 0 1 0 0. This is a 4-bit integer. Okay, so let's say what is this constitute, this will be a 4, correct? 1 2 4 0, yeah, this will be the 4. Okay, now let's say that I will left shift by 1. Okay, so what, how it will look? 1 0 0 0. Okay, what does this value? This will be the 8, correct? This will be the 8, and let's say that I will do the right shift once for on this number actually. Okay, so how does it look? 0 0 1 0. Okay, and how does it what is this constitute to? This will be constitute to 2, right? So what is happening here is, let's say that if I whenever there is a binary number, if I left shift by 1 bit, it will be double. Okay, it will get doubled. Okay, let's say that it is 4 here. Okay, I will left shift by 1 bit, so it will become 8. Okay, and again if I left shift by one more bit, it will become 16. Okay, and again if I do it, it will become 32. Okay, that is the logic here. So what we are trying to do here is we are trying to double our quotient, right? I will double the quotient. I'm checking if that is false within that given dividend or not, right? So I will be doing this, and once I reach that point where like I mean divisor is getting higher than the dividend, right? We will stop there. Okay, so this is the logic to for the left shift and right shift. Now let's check the code. Okay, looking at the code, right? So let's take an example for the earlier example which we took, 33 and 10. Okay, the dividend is 33 and divisor is 10. So what we'll do is we know that we'll have to left shift our well, no, let's for to clearly understand the left shift operator. Let's take an example of 33 divided by 2. Okay, 33 is greater than or equal to 2. Okay, so that is good for calculation. We'll iterate through, we'll go inside, and now we'll left shift our 2 by multiple times until it still stays in that range, right? Dividend, it still stays in that range, we'll left shift it. So we'll try left shifting by 1 bit, and we'll check if it 2 is after left shifting by 2, right? Left shifting the 2, we'll get a 4, right? 4 is less than or equal to 33, correct? So we can, that's a valid one. So we'll update our left shift value, and then we'll update our quotient also, right? How many times, as we are doubling this, quotient will also be doubling. Okay, and we'll left shift again and again until that point we get like 32, right? 32 we'll get, and if you try to left shift again, it will be 64, which is not less than the 33. So we'll stop there. Okay, and now our values looks like is temp divisor would be 32, right? Count would be like 16, correct? And what is the left one now? I mean, now what we are left with is, like, we are left with one more value, right? 33, like I mean 33, and we stopped at 32, so we left with one more value, so dividend will be 1. Okay, and count will be, result value will be like whatever the count we get in this iteration, that will be 16. Okay, and it will look like 1 divided by 3, right? 1 divided by 3 is not a valid one, right? We are not looking for a reminder, right? We cannot get one quotient, so we'll break that loop there. Okay, whatever the value we get, result is equal to 16, we'll return that. Okay, that is one example. Like I mean, that is for 33 divided by 2. Okay, and this got easy, right? Like I mean, like we within one iteration we got completed. So now let's take one more example where let's take one more example, maybe 100 again. Okay, and this time let's take it as 3. Okay, so now what we'll have to do is we'll do the same thing. We'll be left shifting this number until we don't cross this number, right? 3 6 12 12, and then 24 24 48, and then 96, and after 96 it will be 192, right? 192, it will cross our given dividend, so we'll have to stop here. Okay, after shifting, this will be this 96, and quotient would be, I think it will be 32 until so far, right? We have added like 3 plus 3 plus 3 plus 3, and we have added till 36. Okay, now what will happen is, after our left shifting, we are left with four more values, right? So our new calculation would look like 100 minus 96 is nothing but equal to 4, and divided by 3, right? This will be the new loop, 4 divided by 3, and the same thing will go on. So coming back to here, so we'll do the calculation here. Dividend is greater than equal to divisor, and we'll be left shifting until we reach that 96. And once we got that, we'll be updating our new dividend and divisor. Okay, new dividend will be 94, and divisor will still remain as 3. Okay, 4 divided by 3. Okay, and that calculation will go on. Okay, and that's it about this problem. And also we need to handle those negative cases, right? That's what is being written here. And let's say that if it is both are negative, we'll be returning the positive value, right? We'll be storing whatever the result value, right? What would be the result value that we are storing here actually, and we'll be doing the calculation only on the positive values. Okay, yeah, that's it. Thank you.